All right, so we're going to try to do this again with learning about radicals and exponents and all their rules and things like that. Don't forget, if you haven't done so, hit subscribe, hit the like, hit the bell, leave a good comment. All right, here's what's odd in the state of Alabama. All these rules actually used to be part of the Algebra 1 standards, but changed in 2019. So, starting in 2020, we covered them some that first year, and then we didn't the next because it's now Algebra 2 standard. All right, believe it or not, some of the stuff you've already been doing, you just didn't know there was a rule about it. Okay, so for instance, the product rule, same base, add the exponents. Okay, now this possibly could have helped some of y'all this past test where some people said, like, 5x times 2x is 10x. Okay, so maybe we can work on that. All right, so you would just add the exponents. 2 plus 4 is 6. Okay, remember, use the calculator is, you can do that. A power to a power, you multiply them. Okay, well, x to the 4th to the 3rd power, 4 plus 3, 12. All right, power of a product. Now, I know somebody's like, well, what is power of power and power of a product? This one is just one. Okay, this one actually has a product. It has two numbers being multiplied, and it's basically distributive property of exponents. Okay, well, this one gets it to the 3rd, and this one gets to the 3rd. Okay, negative exponent, if it's negative, you move it to the denominator, or if it's negative in the denominator, we move it to the top. Basically, it's the reciprocal. Okay, so if you wanted to add a little caveat right here, you could say reciprocal. All right, this one is one of my favorites because some people never seem to grasp it. Anything to the 0 power is 1. Okay, this is one of those things, that's the rule. It's not a deep thought discussion. That's just the rule. Okay, similar to the what we had earlier, quotient of powers. Well, same base, subtract the exponents, because the other ones were multiplying. Same base, add them. That should kind of make sense. And power of a quotient. Okay, now try to type those out. If you would have actually seen some of the stuff that was in the textbook that y'all don't have, or other things online, it's all this jibber jabber math jargon kind of stuff. Okay, this is what we're focused on. Okay, all right, so let's put these to practice. Number one, this is a power to a power. Okay, so we multiply. So 2 times 1/4, that becomes 2 over 4. And 2 over 4 reduces down to 1/2. And we could write that as a radical if we needed to. We know that that would be the square root of 7, but we're not asked to do that at this point in time. Okay. Number 2, same, square root of 7. All right. So, same thing here. This is 14. 3 times 1/2. Well, this becomes 14 to the 3 halves. Okay. Now, like we did yesterday, we could actually say, this is the square root of 14 cubed. But I'm not asking y'all to go that far. I'm asking y'all for this. Can you do this? Hopefully. Okay. Now, this is a quotient, so we're actually going to be subtracting. So this is 5 to the 1/5 minus 1, because this is to the first power. Okay. Well, 1/5 minus 1 is negative 4/5. Okay. And what do we do? Now, when I said the reciprocal, not this exponent, it's the reciprocal of the base. Okay. So to write this with a positive exponent, we just do that. Let me clean that up a little bit. There we go. Now, I know it's kind of hard to write some of these unless you have like really good handwriting, and we know I don't. To write some of these fractions very cleanly, you know, and some of y'all's handwriting is like trying to decipher, you know, Sanskrit in the Matrix. I mean, it's difficult. Just do the best you can. Okay. All right. Are we good for 1 through 3? Because I'm going to scroll up a little bit. Or I'm going to try. All right. Number 4. We're subtracting again. So this is 10 to the first minus 1/4. Well, that would be 10 to the 3/4. Some of y'all are like, I was not prepared for fractions today. Huh? It's because it's positive. We don't have to do the thing like we did in number 3. All right. Now, number 5. This is what's funny. I was listening to the radio this morning. Yes, I listen to Rick and Bubba. I know I'm an old person. I think it's funny sometimes. But they were actually taking half of the show for one of the guys to learn how to put contacts in. And one of the people that works there, they have a little girl, and they said, if something seems difficult, do it one step at a time. They were playing this kid's song. This one that actually fits for what we're doing for number 5. I would actually distribute first. I would say 6, 5 times negative 1/5 over 9 to the 5th times negative 1/5. Okay. Now, whoops, didn't need to do all that. Now, if we were to clean this up, we would have 6 to the negative first over 9 to the negative first. Because 5 times 1/5 is 1. It's going to be negative. Okay. Now, how do we fix these negative exponents? How? Yeah, flip them. So this 6 at negative first now goes down here. Where does the 9 go? Exactly, it goes to the top. Now, this is what's funny. I actually had a plethora of problems that were actually harder than these that we used to use in Algebra 1. Yeah, like there was like 3 or 4 different variables. There's all types of stuff. I mean, there were some of the problems that we almost used every single power property. Yeah, some of y'all are like, ouch, that kind of hurt. All right, order of operations. What do you do first? Do the parentheses first. So right here, because it's the same base, I'm actually adding these things. Okay. Well, this becomes 7 to the negative 2 over 4. And try to, somebody get the door. Thanks. All right. You could clean that up. This is 7 to the negative 1/2. But now we have to do this parentheses thing. Okay. Well, it's a power raised to a power. So we would actually multiply. 7 negative 1/2 times negative 1. Bam! There we go. So, again, it can be difficult if you try to do all of it at once. Okay? I don't suggest that. And I know some of y'all are thinking, hey, this is not as bad as I originally thought. It's not if you take your time. Now, sometimes it's hard for some of y'all to take your time because you are in a heated debate about who would win between a staring contest between you and a goldfish, or is a hamburger a sandwich? Okay, so I know, just priorities, guys, priorities. Okay, I understand. What? Oh my gosh. Okay, so similarly, we actually have products or properties of radicals. Okay, we have these right here. All right, the product property, it says, 1 times this is actually whatever. Y'all have actually seen this before. Yeah. Square root of negative 4. Well, this is the square root of 4 times negative 1, which is square root of 4 times the square root of negative 1. Well, what's the square root of 4? 2. What's the square root of negative 1? I. Yes, thank you. Okay. So, yeah, we kind of actually had a problem like that yesterday. Anyways, so, excuse me. You've actually seen this before. Okay. And this one's a little new, but with the quotient property, it's really, you know, it can be messy. Now, I don't know how some of y'all, because I've seen your handwriting, some of y'all, you write like this. Okay. Where it looks like something you would see on, like, I don't know, Star Wars or something like that. Uh, I don't know how y'all do that. All right. So let's start practicing these. Yay, practice. All right. We can actually multiply these. 3 times 75. Okay. Well, let's see what 3 times 75 is. 225. Can we take the square root of 225? Yeah. What is that? Yep, 25. Bam. Okay. Well, it's 15 then. What's that? Wow. Bam. That seems fake. Okay. All right, good. See, that's the discussion. If the square root of 225 is 15 or 25, that's the type of discussions that should be happening in class. Okay, now we can do the same thing here. Well, 81 times 9. Shh. So that's actually 729. Now, again, remember with the cube root, 3. Come on, fat finger. You got it. You got it, fat finger. Second, raise the roof. Ah. Then 729. 9. All right. Do, 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 do. So let's see. 12 times 8. 96. All right. So the fourth root of 96 is a decimal. Okay. Now, let's think about it like this. What do we know about 12 and 8? They're divisible by 2. So 2 times 2. All right. So this is 1, 2, 6. That's 4. All right. So 2, 2 times 2 times 3 times 2 times 2 times 2. All right. People are like, that's so many numbers. By the way, apparently we need to. Well, there's a reason why we're getting to this. Believe it or not. We're taking the fourth root, right? Yes. Okay. That's actually the fourth root right there. Yeah, because the twos. So now we can put a 2 on the outside of the house. And then what's left on the inside of the house? Yeah, so what's 3 times 2? 6. Now, another way somebody would have said this are like, oh, you should know that there's a perfect fourth root that's a factor of 96, and you would have divided 16 and 6 because the fourth root of 16 is 2. Or you could just break it down in its smallest parts and do stuff like you've possibly done before. Okay. All right. Trying to see which color I'm on now. All right. What's 9 times 9? Okay, 81. Let's see if we can take the fourth root of that. Ha! We can. 3. Well, I wouldn't assume that's how you put it in the calculator like that. But, if you had a good math teacher, he would have actually tried to show you that on the calculator, you would hit the second, actually, you would hit the 4, if I can find it. 4, second, raise the roof button. I'm having to do this backwards. Whoop, that's a 7. 81. Technically, since we have been doing cube roots and fourth roots for a hot minute, it's your own daggone fault for not knowing by now. I know. I didn't say I was a good math teacher. Well, then shut your face because you're lying. Okay. All right. Now, let's see if we can divide these two. Okay. Well, let's see. 128 divided by 4. I get 32. That's exciting. Okay. Now, I wonder if we could take the fifth root. Now, well, I think we can. I think we just get just a 2. Now, couple of ways I would do this. This is just me. Before I did anything else, I would check in my calculator because I'm a curious person. I like to know stuff about things. I would actually want to see what the square root of 80 was. I'd actually type that in my calculator. Okay, which is 4 root 5 because 80 is 16 times 5. Yeah. Okay. So, what happens with our square roots of 5? Pew! Leaving us with 1 over 4. Some of you are like, how did you do that? Magic. I can do magic. All right. So, some of y'all are going to automatically shut down even more than you already have because I'm about to say, up till now, this has been the easy part. Yes, insert teenage groans and grunts. Ugh, ugh, ugh. Okay. All right. If we had a Wayback Machine, we could actually go back to previously this semester when we were talking about imaginary numbers, and there was a rule about not having imaginary numbers in the denominator. Okay. That rule actually comes from this because I is the square root of negative 1. So this is actually what we're going to have to do. Remember, the conjugate is the same terms, different signs of the bottom. Okay. So what is the conjugate of this gross looking thing right here? 5 root 3, top and bottom. Now, if this is a plus, it's got to be the opposite sign. So what's the opposite of that? Minus. Now, did you say, oh, that again? All right. So, again, if you were to go in the Wayback Machine, okay, we would multiply these. Okay. Now, I know some of y'all are not going to agree with me on this just because you just want to disagree. Totally understand. But I'm going to show y'all some cheat codes. Well, 1 times any of that, that's just going to be right there. Instead of actually having to do like double distributive property and box method, anything like that, there's a shortcut that says we can take the first term, square it, minus the second term and square it. So, 5 minus root 3. All right, what is 5 squared? Okay, what is the square root of 3 squared? No, I'm sorry, what is the square root of 3 quantity squared? All of it. I said that yesterday also. Yeah, Because this is actually the square root of 3 times the square root of 3, which is the square root of 9. Yep. Actually, it does, because this makes perfect sense, because it actually goes with some of the rules we had. Okay, I always told students before to do this. If you have a square root of something squared, that squared basically comes in like a tornado and rips the top off the house. So we're just left with 3. Well, sometimes you got to be graphic to grab the attention of students that probably have been playing video games that's been uh, shooting other humanistic characters for a long time. You don't what? All right, you're just saying no. Why? It's confusing. What part's confusing? Don't say all of it. You have to go from a specific point. Oh, just yeah, I know. It's the multiple steps. I told y'all, teenage brain equates multiple steps to being difficult and confusing and just not worth it. I know it's no that teenage brain has been like that long before social media ever came around. Now, let's look at these 4 problems to hopefully clarify this such confusing topic. All right, we're going to multiply using the conjugate. On the bottom, this is 1 plus the square root of 3. So we would have 1 minus the square root of 3. Because remember, like our definition said above, it's the same terms, just a different sign right here in the middle. All right? So, well, luckily this is 1 times all this, so that's kind of easy. All right? Remember our cheat code, the first term squared minus the second term squared. Okay? So 1 squared is 1. Okay, people got that. The square root of 3 squared is 3. And on the bottom, we would just have negative 2. Now, if you were to use photomath to do this, photomath would actually put it in this format. Okay, that's what photomath would do. So, for my photomathers that still don't think that I know what's up, if I'm seeing this, I'm counting it completely wrong, because that tells me that's the format that you let something else do your work for you. Okay, so you might want to make a note of that. Don't put it in this format. Some people be like, I'm going to do it anyways. I'm counting off my test. Yeah, watch me. What's that teacher man know what he's talking about? Well, that's okay. You can always, fail the course, have to retake it, and good luck with another teacher. All right, 14. What's going to be our conjugate? Yeah, 3 plus the square root of 2. Now, I know this is the first time that we had one that's been a plus. Don't let it throw you off. We're just doing the opposite of this right here, the opposite of that minus. Whoops, I was still in highlighter mode. All right, we have something that's not a 1 up here, so we're going to have to do kind of distributive property. That's going to be fun. Some of y'all, that was a struggle on the test. First term squared minus the square root of 2 squared. Okay, 3 squared is 9, and this is 2. Perfect. Up top, 5 times 3 is 15. What do you think 5 times the square root of 2 is? Yeah, 5 square root of 2. Wow, I actually feel pretty proud. I know I did not expect that to happen. Yeah, I hate the game too. All right, and there we go. I'm just putting the -7 underneath in the denominator. Oh, not -7. There we go. That's more better. It's just 7. Okay. I don't. Now, even though the numbers have changed per each example, has the process changed? No. Okay. It's like some of the things, like I know y'all don't watch regular TV with commercials, but there's some of the stuff like Smuckers, like some of the jams and jellies are like, this is the same process we've used for a long, forever. Okay. When the process works, keep it. That's right. And if it's not broke, don't try to break it to fix it. Some of y'all with the appetite for destruction. Ooh, number 15. Dun, dun, dun. All right. So this time it's going to be the square root of 3 minus the square root of 7. Yes, you can actually do this. Oh, whoa, whoa, whoa. Just about really messed up. Which is way beyond my typical Mr. Jeffries mess up. Woo, that was a good one. Jeffrey's proud, loud sneeze. Hmm. Now, I have had students before that have asked me, they said, Mr. Jeffries, can I just write, because we've had a problem similar to this. They're like, can I just write it like this? Because I don't really like, and it means the same thing, where all they did was, keep this in distributed property mode. It doesn't matter. They're both, actually, they're both the same thing. But remember, I'm wanting one gnarly looking fraction, not two gnarly looking fractions. Because two gnarly looking fractions means that you did what? Photomath. What? That we got one more? All right. So we got one more. Okay. It is. It's lots of fun. Well, we're ending with a good one. Kind of like the saving the best for last thing. We're not. This one is because it actually applies multiple rules that we've learned today, and I'm sticking with that narrative. All right. Now, believe it or not, on this top right here, when we distribute, we know we can multiply those numbers underneath the radical like we did earlier. So what is 6 times 3? Okay. What is 6 times 5? Okay. Now, as we do this, -2, will the square root of 18 simplify any further down? It actually will. Yeah, 3 root 2. Let's check the square root of 30 is square root of 30. Now, I'm doing this with this type of calculators. There's some other ones, some Casios that does it. What is 3 minus 5? Oh, because when we multiply these, remember, it's the first term squared minus the second term. Yeah. Okay. Now, what's actually happening when I'm doing this in the calculator? Well, I'm thinking of the factors like this square root of 18. I'm thinking of the factors that are perfect squares. What's a perfect square that you know will divide 18? 4 is a perfect square, but it's not what we were actually. 9. Okay. Well, this is square root of 9 times square root of 2. Well, square root of 9 is 3. Now, believe it or not, many years ago, that's actually what we would have to do. Okay. Before, some of these newer calculators doing it in certain formats and everything, when Mr. Jeffries had to chisel out his answers on the stone tablets and turn them in and stuff like that. So that's where a lot of this is coming from. Like I was looking earlier at simplifying that thing to the fourth power. No, I'm not waiting for anybody to say anything. All right. And that's it for today's lesson. Don't forget to, yep, hit the bell, leave a good comment, leave a comment. Don't forget to hit subscribe, hit the like, hit the bell. Good stuff, good things. Roll Tide.